Hello, class. Hope everyone is doing well. My name is Yana Kim, and today I'm going to be talking about intermittent fasting. So, upon completion of this presentation, students should be able to describe the physiological process of intermittent fasting, including the hormones involved, identify the benefits and side effects of intermittent fasting, and finally explain the benefits of exercising in a fasted state. So before we dive right into the physiological process of intermittent fasting, there are some key hormones that you guys should know. First is insulin, which is secreted by the pancreas and allows your body to use glucose from carbs in the food that you eat, either for energy or to store for future use. Growth hormone is secreted by the pituitary gland that helps you regulate body composition, blood fluids, muscle, and bone growth, and also sugar and fat metabolism. Next is noradrenaline or norepinephrine, which increases the force of skeletal muscle contraction and the rate and force of contraction of the heart. Next is ghrelin, which is a hormone that gives you the sensation of hunger. And then leptin is a hormone that makes you feel full. And then glucagon is a hormone that stimulates the breakdown of glycogen for energy. And finally, IGF-1 is an insulin-like growth factor that is a hormone involved in growth and development. So next I'm going to talk about the physiological process of intermittent fasting. So first stage is the feeding stage, where during meals the pancreas secretes insulin, where it can immediately be used for energy production, protein synthesis in muscles, or it can be stored later for use either as glycogen or as adipose tissue, which is more of the long-term storage. So during this stage, ghrelin and leptin hormones fluctuate. Um, Usually the leptin hormone increases and the ghrelin decreases. So after about 3 hours, the glucose and insulin levels return to normal. This period is called the growth period, since nutrients are available and the body can burn them, build muscle with them, or store them. So the second phase is the post-absorptive phase. This is when the insulin levels start to fall. The level of glucagon increases, which increases the breakdown of glycogen, releasing the glucose for energy. Glycogen storage usually lasts for 24 hours. And this is when the body switches from glucose to ketones because they're low in glycogen stores. But the exact time that your body starts to shift from using glucose to ketones for energy, it depends on how much glycogen you've got stored away and how much energy you're burning throughout the day. The switch happens faster if you're exercising, since you'll burn through your glycogen stores more quickly. The next stage is the gluconeogenesis. This stage is where the body makes new glucose from non-carb sources, like from fat, ketones, and amino acids. So first, through lipolysis, which is the breakdown of fat, fat cells in the body release free fatty acids. And then the PPAR alpha is a regulator of fat metabolism in the liver, is activated, and this ensures that fatty acids are used for energy. The fatty acids travel to the liver, where they are transformed into ketone bodies by beta oxidation. Ketone bodies that we're referring to are there are three distinct types. First is acetone, the second is acetoacetate, and the third one is beta hydroxybutyrate, or BHB for short. Your body can use either acetoacetate or BHB for energy production. So usually excess protein are broken down as well for glucose, but it's not necessarily protein from muscles that are broken down, because there are many proteins in the body, like in connective tissue, skin, and old cells. And this breakdown of the old cells is called autophagy. This way, the cellular renewal cycle occurs by the body breaking down old proteins and building any necessary proteins that were used. And also, the total ghrelin production decreases, making the overall hunger decrease. The next stage is ketosis, which is the burning of ketones to use as energy. Um, so in this stage, there is a decrease in the IGF-1 hormone. In short term, it leads to less oxidative stress, which is important for anti-cancer and anti-aging interventions, which will be discussed more later on. And then a decrease in insulin and glucose occurs as well, which decreases the risk of metabolic disease. The last stage is protein conservation, which is an increase in the level of growth hormones to maintain a muscle mass and lean tissue. There is an increase in the adrenaline or norepinephrine levels, which prevents a decrease in the metabolic rate. However, presence of the presence of insulin tells the body to stop increasing its production of ketones and plateaus them at a safe level. But since your insulin levels remain low when fasting, this feedback loop doesn't occur. So it is really crucial to consult a medical professional for extremely long fasts because ketoacidosis can occur, which is when there is a dangerously amount of acidic blood from overly high ketone levels. And it's usually seen in alcoholics, diabetics, and cases of extreme starvation. Um, Therefore, all in all, fasting switches the body from burning glucose to burning fat, which then increases the resting metabolism. However, fasting is not recommended for everyone because there are restrictions. So, if you identify as underweight or have an eating disorder, or if you're pregnant and breastfeeding, or if you're under 18, you should not fast because extra nutrients are needed to grow for children. Um, you will also need medical supervision if you have diabetes mellitus type 1 or 2, especially when taking medicine, because longer fast can lead to hypoglycemia. Um, if you take prescription medications, have gout or high uric acid, or have any serious medical conditions like liver, kidney, or heart disease. It's also not recommended to fast for more than 14 days due to high risk of refeeding syndrome, which is when there's a dangerous shift in fluids and minerals when the food is reintroduced after a long fast. However, there have been to be more benefits than side effects found, like weight and body fat loss, even more when paired with exercise, an increase in fat burning, lower levels of blood insulin and sugar, which can possibly reverse type 2 diabetes, an increase in energy and growth hormone, reduced inflammation, an increase in the level of cognitive function, which is related to the BDNF levels, the possible reversal of metabolic syndrome, anti-cancer and anti-aging effects, which will be discussed in more detail next. So there were two main studies I have researched to find these benefits. The first study was a primary study where exercising in a fasted state was found to be beneficial. This study tested 30 overweight men for their fitness and insulin sensitivity and then divided them into three groups. The first being the control group where they just lived their normal lives. The second group ate and then exercised. And then third, exercised in a fasted state and then ate. So the results were that the group that exercised in a fasted state lost twice as much fat during each exercise, even though they all burned the same amount of calories. As shown in the picture to the right, graph A showed that the rates of the whole body lipid utilization was 2 times higher with the fastest state group for the entire 6-week period. In graph B, it shows a decrease in the rate of the whole body carbohydrate utilization during exercise for the fastest state. And then graph C shows a decrease in the respiratory exchange ratio. And then graph D shows that the cumulative energy expenditure throughout the exercise did not differ between the fastest state and the non-fastest state group. They also found an improvement in insulin sensitivity and higher levels of the GLUT4 protein in their muscle that influences how well muscles respond to insulin and use the blood sugar. So in conclusion, it was found that participants would get more out of a workout without increasing intensity or duration by just exercising in a fasted state. So the second study was a secondary article where multiple studies were comprised into one to show the molecular mechanism and clinical applications in fasting. This study found correlations between first is fasting and the brain in mammals. They found an increased level of cognitive function. This is due to the increased synaptic plasticity and increased production of new neurons from neural stem cells. They found an increase in BDNF, which is a brain-derived neurotrophic factor. This enhances production and survival of new neurons from neural stem cells by increasing the network activity. They also found an enhanced parasympathetic activity, which improved the gut motility and reduced the heart rate and blood pressure. And finally, they found an enhancement in the insulin sensitivity, which a reduction in the IGF-1 production, which reduced the levels of oxidative stress and inflammation. Next, some studies found correlations between fasting and cancer, where alternate day fasting caused a major reduction in the incidence of lymphomas and also delayed the spontaneous tumorigenesis, which is a formation of tumors. They also found that differential stress sensitization occurred where low IGF-1 and glucose levels and high IGF-1 inhibitor led to tumor prevention, which promotes cancer cell death. Differential stress resistance also occurs, which promotes protection of normal but not cancer cells. So cancer cells are unable to switch to the stress response mode. However, these findings were only found in mice and not done in clinic due to ethical reasons, so there is no human data available. So next, there was a correlation between fasting and metabolic syndrome. Metabolic syndrome is a cluster of conditions that occur together, which increases your risk of heart disease, stroke, and type 2 diabetes. These conditions include like increased blood pressure, high blood sugar, excess body fat around the waist, and abnormal cholesterol or triglyceride levels. So a study found that in mice, fasting prevented and reversed the aspects of metabolic syndrome by increasing insulin and leptin sensitivity, suppressing inflammation, and stimulating autophagy. Another study found where overweight humans were tested for 6 months. They did an intermittent fasting diet for 2 times a week. They found that they had a loss in abdominal fat, they had an improved insulin activity, and reduced blood pressure. The next is fasting and aging of humans. A study found that inhibiting the mTOR pathways caused by stimulation of autophagy and ketogenesis promoted the potential anti-aging effects. Another study found that IGF-1 paired with insulin was found to be associated with accelerated aging in cancer, and therefore fasting helped reduce the levels of IGF-1. And lastly, fasting and inflammation. So a study in humans found that during a period of fasting, both inflammation and pain were reduced in rheumatoid arthritis patients, but after a normal diet resumed, inflammation came back unless the fasting period was followed by a vegetarian diet. So, in conclusion, I hope that you guys learned that intermittent fasting mainly transitions from burning sugar or glucose to feeding our bodies our own fat for energy. This leads to many health benefits, including promoting fat loss, especially when exercising, having anti aging and anti cancer components, and also reversing the occurrence of the metabolic syndrome. But a lot more research needs to be done, um, especially with regards to the effects of cancer in humans. And also, one should always be cautious when fasting due to the many restrictions and side effects. Thank you so much for watching, and here are my sources in the next slide.